Hello. Okay, let's get started. Hello, everyone. Welcome to SIG API Machinery Deep Dive. My name is Antoine Pelisse. This is Stefan Schimanski, and we have Mike Spreitzer from IBM, and Stefan is from Red Hat. We're going to talk about API machinery, and Stefan is going to start talking about CRDs and some of the new things we are working on. Then I'll talk about ServerSide Apply, and then Mike is going to talk about priority and fairness.
So one topic we are talking in the SIG at the moment about is immutability, so marking things in a CRD as unchangeable. As you know from pod specs, for example, pod specs cannot be changed. Similar things we want for CRDs, and I will start with that. So it's not finished. Everything here is work in progress. There's a cap, there's a PR against the cap to update it. I just want to see, to show what the ideas here are. So the idea is that we can mark fields immutable, mutability, immutable, and then this slice here, so it's defining an array in OpenAPI, cannot be changed. And our question was, what does it mean? Obviously, if you don't change anything, AB to AB, it's fine if you change the order. This looks like some change in the array, so you don't want to allow that. But we quickly came to cases like empty slice versus null. Should it be the same or not? It's not so clear. For many native types, it is. But for CRDs are usually handled strictly, so those differences are preserved. So probably it's not the same. Same thing if you have the slice not at all, so the slice is not defined at all in the surrounding object. Also in the CRD world, it looks different. There's a second way to put immutability on something. Here it's put on the items. So not only the whole array is immutable, but only the items individually. So every item should be unchangeable. And if you do that, so we get similar cases first. Order change is not a good idea. We want to reject that. But maybe removal is OK, because the second element, the second item here in the slice is not changed because it doesn't exist anymore in the result. So one could say, might be the same, and adding something could also be allowed, because the array can be changed, but not the items. But if an item doesn't exist before, it's not really changing. So we're discussing those things. If you want to look for details, the cap is there, and the update of the cap is a PR at the moment. When looking at null and empty, there were different opinions what to do, and in native types, we usually identify them. So null and empty is the same thing, or undefined is the same thing. And but we have done some choices in CRDs. So defaulting exists, will be GA in the next version, and defaulting is strict. So in defaulting, only undefined is defaulted. If you have a null in an object or an empty list, it's never defaulted. So defaulting is strict. So we made a choice not to identify those values. Validation, we have that for ages, and everybody who uses validation. In validation, you can easily distinguish between those special edge cases. So I would say validation is also a strict mechanism we have implemented for a long time. The consequence of that is probably we want also equality to be strict. So always when objects are compared and you have null, you have empty, you distinguish. It's never the same thing. The rule of thumb which we have in mind here is if we define objects are when our objects are equal, when are they equal on the client side, when you have an object in your hands, two manifests, for example, and you consider them equal, then if you do a request with this object to the server, you would also expect that the server does the same thing. So I'm really hand-waving here at the moment. So it's really, really a very rough idea, a rule of thumb or something like that. So if objects on the client side and in etcd are considered equal, and I do something with the objects, I better get the same result, the same response, and I get the same result also in etcd. So we want something like that. So the consequence is probably that we want a strict equality. So we don't want to unify null, empty, and undefined. Native types are different. Everybody knows that if you use Golang types and you unmarshal into them, certain things, they're identified by omit empty. Everybody knows omit empty in Golang code. So we have something which normalizes in native types already. In CRDs, we don't have that at all. And the question is, maybe we should have that. So for many use cases, we don't want to distinguish between those three special edge cases. So maybe we need something similar in CRDs as well. We are looking for protobuf or some variation of binary encoding. And protobuf is even more like that there is no distinction between not defining something in a CRD and empty. So maybe we need something like normalization as well, and we are thinking about that. And if you look on the request pipeline we have in Kubernetes for CRDs, looks like that. All the green bubbles here, the green circles, they are strict. So we have mechanisms like defaulting, I showed that, validation, and the rest logic, so patches and so on. Everything is strict, and maybe we need something which normalizes those values in this pipeline. Basically, repeating what we do with native types, with the Golang unmarshalling, we want to replicate that for CRD. So you get something like the red ones, the red bubbles here. There maybe one should normalize, and we are discussing that at the moment. And actually, there are more places where we have to take on a more fuzzy look on our objects. So actually, I identified those here. I think there are more in admission even, so this might become something in the CRD processing. Immutability also sent us to this topic. So we have something new since 1.16. You can define a list type for fields in CRDs. And a list type, traditionally, it was just atomic. The whole list was either unchanged or replaced by an update. We have two more cases now. You can say a list, an array in a CRD is a set. Then you expect that every element is unique. So there should be some uniqueness check in the CRD or in the CR processing. And we also have a map type where you have a subset of the fields which are keys. So everybody knows containers and pods. They are a list. So the list type is map, and the name is an identifier for each element. And we also support that in 1.16 for CRs. And we have the same thing for maps. If you have a map, you also want atomic as an additional kind or different additional type to maps. Everybody who knows strategic merge patch, we had similar things already before for native types, where you could say how things are merged. So this is all about merging. When you update, for example, here on the left side, we have a map A has a value x, and I update it with B 42, then by default, those are merged. So granular is a keyword here as a type, those are merged. If you change it to atomic, you want an atomic map, it's a replacement. Then if a map is atomic, it behaves like a slice, like an array. Arrays are by default atomic and replaced. So if you have A set to X and you update with B to 42 and it's an atomic map, then just B 42 is the result. A is just dropped. And so this is all introduced for, the original reason was server-side apply, and Antoine will continue with this topic now.
Okay, server-side apply. So when we started implementing this feature, we spent a fair amount of time trying to understand how configuration and objects worked in Kubernetes. And so we went back to the roots, and we realized that Kubernetes is about declarative configurations. What does this mean? It means that multiple people in the system have an opinion about the resources, and they're going to send what they care about, and this is going to be merged together into the object. The object is changed by multiple actors, and they have to collaborate together to have a good, reasonable value. The resources typically specify the intent, and multiple actors are changing it. So the idea behind kubectl apply initially is to allow clients, and by clients I mean mostly users, like human beings, to send their intent to the server and say, hey, this is what I care about, this is what I want the system to look like, please make it so. The problem with that is it doesn't work if you have multiple actors, which means that controllers can't have intent, or at least they can't use client-side apply. They have to either change the object, fetch the object, modify it the way they want it to look like, and then update it, or they have to build a complicated patch. Sometimes it's very hard because if they want to do a strategic merge patch, it just doesn't work. So it's very hard to write a controller that is going to specify an intent. So we consider these use cases. We can look at some other drawbacks of client-side apply. If you're writing a library that is going to send client-side apply, it's very difficult. Constructing the SMP patch is very hard. The protocol is also extremely hard to update because it grew organically. And anytime we update the server to implement a new feature, we have to make sure the client also has the feature, and we need to make sure the two are talking the same language. It's very hard. You also have mostly to use the API Machinery library if you want to do that, which means you have to do it in Go. There is no implementation in Python or anything else. The only other option is to actually use kubectl. And other problems we have is that there is no multi-key associative list. There is no unions. You can have multiple versions. Don't even try to apply an object in a different version. That's not going to work. So we decided to try and fix it. From very far away, ServerSide is about tracking people's intent. And what we've done is that we track fields that we believe people care about. When a client applies their intent, they send us the fields that they care about. And so we're going to track these. And we're going to merge everything on the server so that the resources look the way we think you want it to look. So clients send their entire intent using the server-side apply, but existing controllers can't use server-side apply because they've been built before server-side apply existed. So what they do is that they keep using the update or the patch, and we're trying to guess their intent based on what they changed. So if a controller changes a field, we're going to assume it has an opinion about this value, and we're going to track it. So we have two different workflows now. We have the server-side apply workflow where you specify exactly what you want, and we have the update workflow where you change the resource and we guess what it is. Pretty much, the update workflow is used for anything that exists today, that is post for creation, put for update, patch. This is going to use the update workflow, and if you send an apply, we're going to use all the fields for your intent. The way you use apply is, interestingly, it's a patch. So you just send the object. It's a YAML object. You send the object with all the things that you care about, the values that you want, and we're going to keep track of that. So how do we keep track of what you own and what you don't own? We've built some sort of tree of all the fields that you care about, and we move that inside the metadata of the object. As we can see, it's not just the name of the field, it's also F colon, which is actually useful to understand the structure of the object. We can see F means fields, and we also have a K name sidecar. This is useful to understand that containers are lists, but the lists are actually maps, and so we can track the object by looking at the key. So for each person that applies, or modify the object, and for each version, we have this set of objects that they own. We can have some of the fields can be owned by multiple people. So if two persons apply the same value for the same fields, it's going to be tracked by the two persons. If any of the person tries to change the value, then it's going to cause a conflict. You can force the conflicts. We're going to see that next. And yeah, so conflicts. When you do an update, so if you modify the object or send a patch, which is the case for most controllers, we are going to automatically grab the ownership of the fields. That is because we don't want to break backwards compatibility. So if a controller is used to update or send a patch, it's going to have to succeed. It can't fail now. So we're always going to change the ownership of the field. So if I'm the HPA and I'm trying to change the replica of an object, anytime I change this replica, I'm going to own that field. Apply has more use cases. So when I'm trying now with apply to update this number of replica, if it's owned by someone else, I'm going to end up with a conflict. And that's actually a feature. We don't want people to override values that they don't own by accident. If the HPA has decided that the value should be this, then you should either decide that you have the ownership of the field and you have the opinion, or you have to give it up. Merging. Merging is extremely simple. We just take the current object and we apply the new configuration on top of that. When I'm saying simple, of course, I'm lying. It's very, very complicated. What we have to do is that we want to remove the items in the maps that you don't care about. So for example, if you had a container and you decide to change the container for another container, we need to realize that you remove the other container. So we can't just apply blindly. We have to find that you had this container before, you don't have it anymore, and nobody cares about this container. And we also have to do that across versions, which is pretty complicated. There are quite a few features that we're missing, or not features, but bugs also we have. So we have a lot of problems with performance. It's keeping us pretty busy. Since we are definitely on the critical path because we have every single update, post, patch, and apply operations to track, that's a lot of work for the API server. So we're trying to reduce the performance impact. Also, since we are tracking the fields for every single modifier of the object, this is a lot of data that we have to add to the object. So we're trying to make sure that this field set is as small as possible. We're also working on unions, which is not completely well-defined yet. Another interesting feature that we want to implement is the ability to remove fields. While I said that you declare the opinion and the things that you care about, you have absolutely zero way to say, I care about this not existing. This is just the nature of the object. We don't have a good way to say, I don't want this. So we would like to implement a way to say, I want these to be removed, or I want these to not exist. This would be extremely convenient for controllers. And ideally, we would like to track mutation from mutating webhooks, but again, because of performance, we can't perform all these operations for every single mutating webhooks. Mike.
So, we don't have the updated slides. CRUD. Well, when you look at it at home, you'll find the names. I'm working with a few people. Aaron Prindle and Daniel Smith from Google, Bruce Ma, and Tony He and Min Jin from Ant Financial, and myself. Okay, can we tune the echo down a little?
Do you want to move this way?
Okay, I'll try that. So, no, it's not helping at all. Okay, that's better. All right, so we're working on adding a new feature. There's a KEP for it about API priority and fairness. The concern is getting some self-protection in the control plane. Currently, buggy controllers, buggy or aggressive clients can take down the control plane just by overloading it. We want to provide some self-protection. So the basic idea you first think of is rate limiting. It occurs to us that it matters that some requests take longer to serve than others, so we want to really look at the product of the request rate and how long it takes to serve each request. And if you think about it in a minute, that averages out to number of requests executing. So what we're going to do is regulate requests executing. And really, this is just a more sophisticated version of the max in flight handler that's there today. The existing one makes a simple distinction between mutating and non-mutating requests, which we think is actually not very interesting anymore. We're more interested in distinguishing where these requests are coming from and what they're doing. Oh, there it is. Okay. All right. So the basic idea is this is a filter. It goes into a handler. It goes into the existing handler chain. I've zoomed way in on the new handler. There are some earlier handlers and some later handlers. and we can debate about whether it's in the right place. We're still working on that. But the basic idea is there's two concepts here. There's priority levels. We're going to classify the traffic and assign it to priority levels. So the first stage is classification. We have a series of flow schemas. Each request is matched against flow schemas in turn. The first one that matches is the one that determines it. A flow schema is, as the name suggests, the description of a collection of flows. For each flow schema, its flows are mapped to a priority level. And then a priority level describes what to do with it. Each priority level has a request concurrency limit, and then a choice for how to handle things that exceed the limit. We can either drop them or queue them. Also, some priority levels are exempt from this limitation at all, and that's important. All right. And if it's queuing, there's a set of queues that are configured. We use a technique called shuffle sharding, which lets you actually get a lot of independence with a relatively few number of queues. So away we go. Let's look at some example configurations. So for a priority level, maybe we start in the bottom right here. The simplest kind of priority level is one that is exempt from controls. It just says, hey, I'm exempt. Next level up in sophistication, top right-hand side of the slide, is a request priority level that says, okay, I'm going to have concurrency limits, but I'm not going to do any queuing. So you see there's a parameter called assured concurrency shares. So what we do is, at the API servers options, there's already parameters to configure a concurrency limit that's used by the maximum flight handler. We repurpose that, okay, and we divide it up proportionally amongst the priority levels that are not exempt. And the shares is just their proportion. Okay. So that kind of logic, so the shares together with the overall limit determines the absolute number limit for this priority level. And that's all there is if there's no queuing. If a request, if a request comes in for a priority level that's already at its max, the request will get dropped or rejected, to be more precise. Now let's look left-hand side of the screen here, a more complex example where we're doing queuing. Okay, we still got the same parameters for the concurrency limit, but we've now also got queuing parameters. We've got a number of queues. We've got a hand size. That's the shuffle sharding. The metaphor is you shuffle a deck and deal a certain number of cards, which is a number of queues. Then we're going to pick the queue that has one of the queues that has the shortest length to put the new request in. And then we also have some limits on how long things can sit in the queue. One is there's a time limit, and that's an API server parameter. And there's also a length limit for each queue, or each priority level has its individual queue length limit. All right, so that's priorities. On the flow schemas, we borrowed a lot of concepts here from RBAC and adapted them and recast them. We realized that in RBAC, there's actually a lot of union structure that's not done in the usual way we do unions in our API models. So we revised it to follow the usual patterns for unions. Okay, so there's a couple of concepts here. There's, like in RBAC, there are subjects, verbs, and objects, or targets, we say, because everything's an object. So subjects, there are three kinds of subjects we can match on, like in RBAC. General user, or by matching by user name, user groups, and service accounts. For targets, there's either a resource style target or non-resource style target. You see an example here of a non-resource style where there's just a verb and a URL pattern. For the resource style, we have the usual terms in our API. We have API groups, we have the resources, and we have namespaces. Let's look at another example to bring in a couple more things. We can talk about resources that are not namespaced. We can also talk about requests that are for all namespaces. And that's matched with this cluster scope Boolean. Here's also an example of a service account where we talk about the namespace in the name of the service account. So, there we are.
We're going to take questions. We have 5 minutes, right? 10 minutes.
But have you also considered any work to allow users to configure where the CRD data is stored per CRD type?
That's already there.
So you
For API group, it's already there.
So the API server allows you to like push all CRD or a particular type. So a different store, but
CRDs.
Yeah, but for CRDs, like when I register CRD and I want it to be my own etcd, because the lifetime of that thing may be more than the lifetime of the system.
I'm not sure I understood the question. Whether there's a configuration to send to different etcd clusters or what?
Yeah, different API, right? For native things, right? We can configure it on a API.
Yeah, there's actually a work in progress PR fixing that at the moment. Technically, it's possible. We had discussion to build something like a storage configuration layer, so something more abstract and more official. But I haven't. So this is really early. So if you're interested in that, yeah, join the discussion, speak to the people from the SIG. But no, at the moment, it's not possible.
Okay, so the question is, if there is a conflict, how do you know what the conflict is and who do you have a conflict with? So we actually keep track of who has made the change or who owns the field. We keep track of the time when it happens. So pretty much, if you have a conflict and you try and change the number of replicas, it's going to send you an error saying that you have a conflict with the HPA that changed the value at this given time. So we know exactly what is the cause of the conflict. Does that answer your question?
Yeah, so I was thinking warrant is like historical.
So we're not keeping track of the entire history for size reason, but we keep only track of the last change made by a specific controller or user.
I would say it's not only for size reasons, but it's logic, right? I mean, logically, there's this takeover of ownership, right?
Yeah, yeah.
Where can we find these slides?
They will be attached and updated on the schedule. So I think there's an old version. No, there's none maybe at the moment. I'm not sure. We will attach them.
Thank you.
Thank you very much.
Thank you.